Okay, hello everyone. So today we will learn about discrete probability distribution. So the learning objective for today is to understand the difference between discrete and continuous random variable, to compute the expected value and variance of a discrete probability distribution, and then to compute probabilities from the binomial and Poisson distribution. Okay, what is a probability distribution? So probability distribution is a listing of all possible outcomes of an experiment, or we can say random variables, and the probability of each of these outcomes. So for example, we have experiment, a die is rolled once. So from here we can list the sample space, and then this one, if you still remember, the sample space will be 1, 2, 3, 4, 5, 6. So this is all the sample space. Okay, and then we can write x. Let's say x, our random variable, is the numbers that show. So we can say x is the number that show. When the dice is rolled. So we can write x as the 1, 2, 3 until 6 here. 4, 5, 6. And then the P of x here is actually the probability of each of these outcomes. So we know probability of getting 1 is 1 over 6. And then probability of getting 2 is also 1 over 6. And then probability of getting 3 is 1 over 6. And so on. So this one is also 1 over 6. Probability of getting 6 also 1 over 6. So these are the probability distribution, or we can say discrete probability distribution. So a random variable is a numerical value that represents the outcome that occur randomly in any experiment. So the keyword here, it should be numerical value, and it should be the outcome that occur randomly in any experiment. So we denote as x. So just now, our x is the number that show when we roll a die once. So for example, another example is tossing a coin 2 times. And then, okay, if you remember, if we toss a coin 2 times, we can get the sample space here will be head, or head-tail, tail-head, or tail-tail. So these are all the sample space, all the possible outcomes. But remember, the random variable must be numerical value. So for this one, this is not numerical value, so this one cannot be a random variable. But we can say the example of random variable for this one, for the experiment, is like observe the number of head in this experiment. So we can say x is the number of head. Then we can count. So for example, for this one, actually we have 2 heads showing, and then this one 1 head, this one also 1 head, this one like 0 head shows. So for this one, for this experiment or random variable, we can list all the x and also the probability for each x. So we can put in a table. So x here, it can be starting from 0, means no head, or 1, or 2. So this one is based on the sample space here. And then probability of getting 0 is actually only 1 over 4. And then probability of getting 1 is actually 2 over 4. And then probability of getting 2 heads is 1 over 4. So from here we get this. So this is the random variables. X is the random variables, and P of x is the probability of getting each outcomes. So this is called the discrete probability distribution, or discrete random variables. Okay, there are 2 types of probability distribution. So the first one is discrete probability distribution, has discrete random variables. And then second one is continuous probability distribution, has continuous random variable. So what are these two? What are the difference between these two? So let's look at discrete probability distribution. So for this one, we can assume only a certain number of separate values. So remember here is only a certain and then separate values. So basically it's not continuous. The value is not continuous, separate values. Okay, it is usually the result of counting something. So we want to count something, and then we know when we count starting from 0, 1, 2 and so on, it's actually separate values when we count something. So for examples, so the number of heads showing face up on 3 tosses of a coin. And then another example is the number of houses painted in a week, or the number of workers employed. So all these things is like we count something, so it is discrete value. So next one is continuous probability distribution. So for this one is actually any values within a given range. So we have range, so it can be continuous but within this range. So it is usually the result of some type of measurement. So for example, the distance student travel to class. So the distance can be continuous, can be any value in a given range, or the length of a time of a particular phone call. So basically the time taken, or the weight of a can of tuna, the weight. So and some type of measurement can be continuous probability distribution. Okay, main features of discrete probability distribution. So we have 3 features. So the first one is the sum of the probabilities of all the outcomes is 1. So this is actually sigma symbol, or we can say the summation. The sum of all P of x, the probability must be equals to 1. So if we add all the probabilities, it will be equals to 1. Okay, and then second feature is that the probability of particular outcome must be between 0 and 1, or we can have this symbol. So P of x is greater than or equals to 0 and less than or equals to 1. Okay, and then the third one is the outcomes are mutually exclusive events. So basically, each outcome cannot occur at the same time. Okay, it must be mutually exclusive events. Okay, let's look at example 1. So the Pizza Palace offers 3 sizes of cola. So we have small, medium and large to go with its pizza. And then colas are sold for 80 cents, 90 cents and $1.20 respectively. So basically this one is for the small, 80 cents for the small, and then 90 cents for the medium size, and then $1.20 is for the large size. And then 30% of the orders are small, and then 50% are medium, and then 20% are large. So organize the sales of cola into a probability distribution. Okay, remember probability distribution, we have discrete or continuous. So for this one, remember this one should be numerical values. So instead of we have the small, medium and large, we should have numbers that represent small, medium and large. So for that, the X will be the price. So X is actually the price of cola. So we have the small price is 80 cents. So we have 0.80 here, 80 cents. And then over here will be the 90 cents. And over here will be $1.20. Okay, and then the probability of getting each one is actually probability of it is being sold. So remember the small, 30% of the orders are small. So over here will be 0.3. And then for the medium is 50%. So here is 0.5. And then the large is 20%. So over here is 0.2. Okay, so basically everything here is in this table, the X, the random variable and also the probability. Okay, the question here now, is this a discrete probability distribution? Okay, and then indicate why or why not. Okay, the answer is it is a discrete. Okay, the reason is because the random variables here are separated from each other. So we have very specific value, 80 cents, and then 90 cents and 1.2, and then they are separated values. So it is a discrete instead of continuous. Okay, and then when we add everything, so 0.3 plus 0.5 plus 0.2, we get equals to 1. So the total probabilities is 1. So this one is the first features just now. And then if you look at each of these, this one is 0 0.2, 0 0.5, 0, 0.3, 0 0.5 and 0 0.2. So each one of these P of X is actually in between 0 to 1. So this one is second features. And then the third, the outcomes are mutually exclusive events. So if the orders is actually the small, it cannot be medium and large at the same time for that particular order. So they are mutually exclusive events. So the answer here is yes, it is a discrete probability distribution. So basically, if the question asks about whether it is a discrete probability distribution, so first we have to check for the discrete. And then next, you have to check all three features for probability distribution is satisfied. So the sum is equals to 1, and then the probability for each is between 0 and 1, and then there are mutually exclusive events. Okay, next we want to learn about the mean, variance and standard deviation of a discrete probability distribution. Okay, the mean of probability distribution. So this one we use the symbol, the mean or mu, we say mu. Also equals to the expected value of x, expectation of x, E of x, which is equals to the sum of x times P of x. So this is the formula for E of x. Okay, E of x equals to the sum of each x must be multiplied by the probability P of x, and then we get the sum of all of this. Okay, so this is the formula for the mean. Okay, next is the variance of probability distribution. So the variance is the symbol sigma squared, which is the variance of x. Okay, the formula is this formula, E of x squared minus the mean square. Okay, and then E of x squared so E of x squared is equals to, okay, if inside the bracket here is x, over here must be x. So for E of x squared, this one will be sum of, over here must be x squared times the P of x. So inside bracket here is x squared. So over here also x squared. So this is the formula for E of x squared, and then minus the mean square. So basically, this is the formula for variance. So this formula you don't have to memorize. You don't have to remember this because it will be given in the formula booklet. Okay, next, what is standard deviation? So standard deviation is basically sigma. So variance is sigma squared, standard deviation is sigma, or we can say the square root of variance. So once you have gotten the variance, you just square root the variance to get the standard deviation. Okay, what is the meaning of mean? So basically mean, it reports the central location of the data, the average, the central location. It is also the long run average value of the random variables. So basically in the long run, we expect the value to be that value. It is also referred to as its expected value, or E of x, expectation of x. Okay, what about variance of a probability distribution? So this is the formula, E of x squared minus mean squared, or sum of x squared times P of x minus mean squared. So variance is actually measures the amount of spread or the variation of a distribution. And then it is the standard deviation. The standard deviation is the square root of the variance. So if we have like we say the distribution of the probability is like this. So the mean will be the central here. So this one will be the mean. And then the variance is actually the spread here. So this one is the standard deviation, or sometimes the sigma squared, the variance, the spread of the data. Okay, let's look at the same example here. So we know this is already the discrete probability distribution. So now we want to calculate the mean for this. So remember, this is the formula for mean. Mean, mu equals to E of x, which is equals to sum of x times P of x. So the way I normally do this, I would suggest you guys, we have this table, so we just add another row or another column using this table. So for this one, we add another row. So this row is for x times P of x. So basically, for each x, we multiply with its P of x, the probability. So for this one, 0.8 times 0.3. So we get 0.24. And then 0.9 times 0.5. We get 0.45. And then 1.2 times 0.2, we get 0.24. And then once we calculate this x times P of x for each x, then we can add. So we add, we sum everything. This one we get 0.93. So hence, we actually get the E of x or the mean, which is the sum of x times P of x. And then the sum here equals to 0.93. So basically, we just add everything. So once we have done multiply each x times P of x, so we just add sum everything. So this gives the mean for the probability distribution. Okay, again, the same thing. Now we want to compute the variance and the standard deviation. Okay, and then I just put the variance here. The formula, variance of x equals to, so the formula will be E of x squared minus mean square, or the E of x squared is actually sum of x squared times P of x minus mean square. So mean, basically we already get this one, mean. So we know mean equals to 0.93. So now we want to calculate x squared times P of x and then get the sum. So again, we add another row here. So just now we get this one, x times P of x. So I just fill up this row. So this one is 0.24. This one is 0.45. This one is 0.24. So now we want to calculate x squared times P of x. So this one means this x, we square to the power of 2, and then we multiply with the P of x. So this one is 0.8 squared times 0.3. So we get 0.192. And then this one, 0.9 squared times 0.5. So we get 0.405. And then this one is 1.2 squared times 0.2. So this one we get 0.288. So again, we can add everything here. We sum everything here. So the sum here equals to 0.288. Sorry, 0.885. 0.885. So now, once we have done calculating this, so we can use the formula to get the variance. So the variance, or the symbol, is actually sigma squared, which is the variance of x, which is equals to sum of x squared times P of x minus mean square. And then this one is equals to, so this is the sum of x squared times P of x, so 0.885, and then minus 0.93 square. So the answer here is 0.0201. So this is the variance, sigma squared. So now we want to calculate the standard deviation. So standard deviation is sigma, which is equals to square root of the variance. So which is square root of 0. Okay, let me So square root of 0.0201. So the answer here is equals to 0.1418. So this is the standard deviation. Okay, let's look at another example. Example 2. So we are given the probability distribution of a discrete random variable x in this table. So the value of x equals to -2, -1, 0, 1, 2. And then we have the p of x here. And then the p of x here is in terms of k. So we have k and then 0.5k and so on. Ka, find the value of k. So k is a constant value. So how to get this one? So remember, we know the total probability of a discrete probability distribution should be equals to 1. So sum of p of x must be equals to 1. So to get k, we just add everything equals to 1. So we add this everything, this whole thing, and then we equals to 1. So this one we have k plus 0.5k plus 0.25 plus 2k plus 4k equals to 1. So for this one, when we solve, so you guys can try solving this. So when we solve for this one, we can solve for k, we get k equals to 0.1. So we finish this a, k equals to 0.1. So once we get k equals to 0.1, so we can write down this value of each p of x here. So this one is going to be 0.1. And then this one, second one here is 0.05. And then this one is 0.2. Over here is 0.4. So these are all the p of x for each x. Okay, and then next one we want to calculate e of x. And I remember the formula for e of x is sum of x times p of x. So we add one row here for x times p of x. So we calculate each x times p of x. So for this one, minus 2 times 0.1. So you get minus 0.2. And minus 1 times 0.05, you get minus 0.05. And then 0 times 0.25, we get 0. And 1 times 0.2, we get 0.2. 2 times 0.4, we get 0.8. Okay, and then when we add everything here, we get 0.75. So we know this one is equals to 0.75. So this is the mean. The expected value e of x are also equals to the mean, mu. Okay, now we want to calculate the variance. So variance of x equals to sum of x squared times p of x minus the mean square. Okay, again, we add another row here for x squared times p of x. So remember this one is minus 2 squared times p of x. So for here we get 0.4. So I just give the value. So you guys can calculate this one yourself later. So this one is 0.05. Over here is 0. Here is 0.2. Here is 1.6. And then again we can add everything here. We get 2.25. So this one is equals to 2.25 minus 0.75 square. Okay, just put the value for variance below here. The variance is equals to 1.6875. Okay, this is the variance, and then we need to calculate the standard deviation. So the standard deviation is sigma, which is equals to square root of variance. So square root of 1.6875. So we get the standard deviation here is equals to 1.299. Okay. So now we finish this one. So so basically in discrete probability distribution, there are a few spatial distribution. So for this lecture, we will only learn about two special discrete probability distribution. So the first one is binomial probability distribution, and then the next one is Poisson probability distribution. Okay, what is binomial probability distribution? So the characteristic one for binomial is there are only two possible outcomes. So either success or failure. So only two possible outcomes. Can you remember when you see any experiment that contains only two possible outcomes, that one can be binomial probability distribution. So for example, if you're interested on the number of heads that turn up, then the outcome is considered as success if a head appears, or failure if we get a tail. So this one is an example of either success or failure. So another example is we can have like true or false answer, absent or present, good or defective, sales or no sales. So either success or failure. Okay, only two possible outcomes. So characteristic number one. Okay, characteristic number two is, so the random variable is the result of count. So basically we count the number of success. So we count the number of success in the total number of trials. So for example, let's say we have n trials. So we count the number of success. So this one, the x, it can be starting from 0, means no success. And then one success, and then 2 success, and so on, up until n success, because we only have n trials. So the maximum number, the count here must be n, number of trials. So for examples, if head appears 4 out of 5 trials, so for here we have n equals to 5 trials. So then the random variables will take the value x equals to 4. So for this one, the x can take value 0, 1, 2, 3, 4, 5, up until 5 only. The maximum number will be number of trials. Okay, and then if there are 10 true or false questions, so we count the number of correct answers, or the number of the true answers. So x can take the value of 0 true answers up until 10 true answers. So the x is the count of success, starting from 0 up until n. Okay, the maximum number will be n for binomial. Okay, characteristic number 3 is the probability of a success remains the same from one trial to another. So this one is the same. Okay, and then we denote the probability of success by pi. We use the symbol pi or p. So normally I use p for probability of success. And then the probability of failure is denoted as 1 minus pi, or we can say q equals to 1 minus p. So since we know for binomial it's only either success or failure, so if probability of success is p, so probability of failure will be 1 minus p. So example, in each trial, the probability of getting a head, pi is 0.5. Okay, and then another example is in each true or false questions, so the probability of guessing a correct answer is 0.5. Okay, characteristic 4, number 4. So each trial is independent of any other trial. So the outcome of a particular trial does not affect the outcome of other trial. So that is why the probability of success remains the same throughout the trials. And then remember, independent, probability of A and B equals to probability of A times probability of B. So independent. So we just multiply all probabilities. So this is the formula, binomial probability formula. So let's say if the random variable x is binomial distribution, so we can write as the symbol x. So we use this symbol. And then we use b for binomial. Okay, and then the characteristic for binomial will be characterized by the number of trials n and also the probability of success pi, or we can use p. So probability of x equals to some value of x is equals to n choose x and then times probability of success pi to the power of number of success x and then times probability of failure 1 minus pi or 1 minus p or q times to the power of how many fail n minus x. So or this one we can write as, if let's say we use the p and q, so the n choose x is how many success, and then p to the power of success, how many success, and then times q to the power of how many failure, which is n minus x. So C actually denotes the combination here. So this one is the combination, and choose x. Okay, n is the number of trials, x is the number of success, and then pi or p is the probability of success. So this is the formula for binomial. Okay, and then the mean and variance. So the mean for binomial is actually, the formula is n times p, and then the variance for binomial is n times p times q. Okay, so steps in answering probability questions. So for this one, let's say we know the random variables, and then we first define the random variable x. So for example, the number of heads. Okay, and then next one, we state the type of probability distribution involved. So let's say it has special one. So we can say, let's say it is binomial. We write like this, x, and then this symbol, b, and then bracket, and p. So n is the number of trials, p is the probability of success. So example here, a coin is tossed 3 times. So we can say this one. Okay, and then we are interested in the number of heads. So we can write x is the number of heads. Okay, and then this one we can say n is the number of trials. N equals to 3 because we toss 3 times. The number of trials is 3. And the number of heads, it can be either 0 head or 1 head, 2 head or 3 heads. So x equals to set of 0, 1, 2, 3. And then n equals to 3 because there will be 3 trials. And then pi is the probability of success. So let's say success is the we are getting heads. So the pi or p equals to 0.5. So for this one, since it is actually considered success and failure event, so it is considered binomial. So binomial 3, 0.5. So this one is the n, this one is the p. Probability of success. So let's look at example here. So in a binomial distribution with n equals to 4 and then the pi equals to 0.6, so find the following probability. So we know it's a binomial, so x is a binomial, and then n equals to 4, p equals to 0.6. So from here we know q equals to 0.4, 1 minus 0.6. Okay, now we want to find probability of x less than or equals to 1. So this one is actually equals to probability of x. So remember the n equals to 4, so x equals to either 0, 1, 2, 3, 4 up until n. Starting from 0 up until n. Okay, and then when probability of x less than or equals to 1, this one is actually equals to probability of x equals to 0 or x equals to 1. And then remember for discrete, the equal sign here is very important. So it's very different if there is equal sign or if there is no equal sign. So for this one, there is equal sign. So we want probability of x equals to probability of x less than or equals to 1. So that's why we have probability of x equals to 0 or probability of x equals to 1. And then remember, probability distribution is actually mutually exclusive events. So probability of x equals to 0 cannot happen at the same time x equals to 1. So this one equals to probability of x equals to 0 plus probability of x equals to 1. Okay, and then we have this one. This is when we use the formula, binomial formula that we learned just now. So this one equals to n, choose 0. So we have 4, choose 0. And then the probability of success is 0.6 to the power of how many success, which is 0. And then times probability of failure, which is 0.4 to the power of how many fail. So basically, if 0 success, that means 4 times fail to the power of n minus x. So 4 minus 0, so we get 4. Okay, this one is for probability of x equals to 0, and then plus this one is for probability of x equals to 1. So 4, choose 1, and then 0.6 to the power of 1. And then probability of failure, which is 0.4 to the power of 3, n minus 1. 4 minus 1 is 3. So now this one, you guys can calculate this one using calculator. So this one is actually equals to 0.0256 plus 0.1536. So the answer here is 0.1792. Okay, so we are done with A. So let's look at B. So we want to calculate probability of x greater than 1. So this one is actually equals to, okay, remember here, greater than 1 without the equal sign. So this one is actually probability of x equals to 2. 1 is not included, so probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4. Or actually you guys can use the complement rule here. So remember this complement rule, this one is actually equals to 1 minus probability of x less than or equals to 1. So over here is greater than 1. So when we complement, it should be less than or equals to 1. So we include the equal sign here. And then we already calculate the probability of x less than or equals to 1 above. So this one is actually 1 minus 0.1792. So this one is equals to 0.8208. Okay. Okay, so basically we also have binomial probability table. So this one also will be given in the formula booklet. So you guys can use the table. So how do we read the table? Okay, let's say we have n equals to 4, the same question, n equal to 4, and then pi or p equals to 0.6. So the first thing is you look at the n. So you look at the first column here. So we find n equals to 4, which is this one. So now we only focus on this part. Okay, n equals to 4. And then next one, we look at the p, 0.6. So this is the p. So from here, you find 0.6. So this is actually the 0.6. So only focus on this column. So basically this column and this part. So we only focus on this part only for this question. Okay. So we want probability of x less than or equals to 1. So this one is probability of x equals to 0 plus probability of x equals to 1. Okay, and then how to get this one? And then we see from here, actually we have this one, 0, 1, 2, 3, 4. So this is where x equals to 0. So then we want probability of x equals to 0, which is equals to this one, 0.026, and then plus probability of x equals to 1, this one, which is this one, the second one here. So 0.154. So we just add these two, so we get 0.18. So this is actually the same as before. We get the same answer, this one. Okay. So the same thing for this. This one is actually probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4. So basically this one is the 2. So 0.346, and then this one is the 3 plus 0.346, and then this one is the probability of x equals to 4 plus 0.130. So when we add together, we get 0.822. Okay, basically the similar answer to previous one. So it's up to you whether you want to use the calculator, the formula, or you want to use the table if we can find the value inside the table. Okay, let's look at next question. So a coin is tossed 3 times, and then we are interested in the number of heads. So find the mean and the variance. So remember this one, we already discussed as before. So for this one, they say x is the number of heads. And then we know x is a binomial distribution because the success is like when we get heads, and a failure when we get tail. So we have success and failure event. So this one is actually binomial with n equals to 3 because we toss 3 times, and then the p equals to 0.5. So once we get this, we can straight away get the mean and the variance using the formula. So the mean, which is equals to the e of x, the formula here is n times p. N times p, which is equals to 3 times 0.5, which is 1.5. And then for the variance, sigma squared, the variance of x, this one, the formula is n times p times q. So we have 3 times 0.5 times q, which is also 0.5, equals to 0.75. So this is the answer for this question. Okay, let's look at next question. So a machine that produces stamping of automobile engines is malfunctioning and producing 10% defective. Okay, and then the defective and non-defective stamping proceed from the machine in a random manner. So if the next 5 stamping are tested, so we want to test the next 5 stamping. So find the probability that 3 of them are defective. So this one is actually defective or non-defective events. So basically we can say success or failure event as well. So success if we get the defective. So X is actually the number of defective. Okay, and then for this one, since defective count as success, so we know the probability of success is the probability of defective, which is 0.1. Okay, and then we can get Q is 0.9. Okay, and then N, the number of trials. So since we want to test 5 stamping, so the N is 5. So we can say X is the binomial distribution with N equals to 5 and then P equals to 0.1. So we want to find probability that 3 are defective. So we want to find probability of X equals to 3. So we can use the formula 5 choose 3 and then times 0.1 to the power of 3 and then times 0.9 to the power of 2. So this one we can get the probability equals to 0.0081. Okay, for this example, I want you guys to try yourself. So I will give the final answer. So for A, the final answer is 0.0282. Okay, and then for B, the final answer is 0.6172. And then for C, the final answer is 4.5. So you guys try yourself. If you have any questions, then you can email me or text me on Microsoft Teams. Okay, let's look at the next one, Poisson probability distribution. So for this one, it describes the number of times some event occurs during a specified interval, or we can say the average number of times in specified intervals. So the keyword here is actually specified intervals. Okay, so the interval may be time. So time can be like in a day, or in a week, or in a month, in a year. So that one will be time, or distance, in a kilometer, per meter or anything. Or it can be also like area or volume. Okay, for examples, so the number of accidents, so basically we count number of somethings, or like average number of somethings, in a given manufacturing plant per month. So we have the interval per month here. Or another example is the number of errors per 100 invoices, the number of breakdowns of a computer per week. So for Poisson, it's actually the interval is very important. Okay. Okay, this is the formula for Poisson. So let's say we say X is Poisson distribution. So we can use the P, and then the characteristic here is only the mean, the mu, the average. Okay, and then the formula P of X equals to some value of X is actually the mean mu to the power of X, and then times E to the power of negative mu divided by X factorial. So the mu is the mean number of successes in particular interval, and then the E is the exponent function, and then X is the number of success, and then P of X is the probability of specified value of X. Okay, for Poisson, the mean is actually equals to the variance equals to the mu. So mean equals to variance equals to mu. The same thing, mean and the variance for Poisson distribution. Okay, let's look at example. Okay, given that X has a Poisson distribution with mean 0.3, mu equals to 0.3. So we have X, Poisson, and then the mean is 0.3. Okay, find probability of X equals to 0. So for this one is equals to, so we use the formula, probability of X equals to 0 equals to mean to the power of X and then times e to the power of negative. So basically this is the formula, mean to the power of X and then e to the power of negative mean, negative 0.3, and then divide by X factorial. So divide by 0 factorial. So for this one, you guys can just use the calculator. And then this one, the answer here is 0.7408. 7408. Okay, now let's look at B. So we want to get probability of X greater than 0. Okay, basically for Poisson and binomial, for Poisson, it's actually we count the number of something or the average number of something in specified interval. And when we say we count, so the number can goes up to infinity. So that is the difference between Poisson and binomial. So for binomial, the maximum value of X is only up to the number of trials. But for Poisson, the S can goes up to infinity. So for example, this one, we want probability of X greater than 1. And then again, we don't include 1 because we don't have the equal sign here. So this one is actually probability of X equals to 2 plus probability of X equals to 3 plus ... up until infinity basically. Okay. And then we cannot calculate up until infinity. So what we can do is, for this one, we use the complement rule. So this one is actually 1 minus probability of X less than or equals to 1. So for the complement, we include the equal sign. So this one is 1 minus, and then put bracket, probability of X equals to 0 plus probability of X equals to 1. And then close the bracket. Okay, and then this one is 1 minus, and then probability of X equals to 0 we already get from question A. So 0.7408 and then plus. So probability of X equals to 1. So this one we use the formula. So this one is e to the power of minus mean. So minus 0.3. And then the mean 0.3 to the power of X to the power of 1 divided by 1 factorial. So when you guys calculate this one, the final answer is actually equals to 0.037. Okay, so remember for Poisson, S can goes, the number of S can goes up to infinity. Okay, let's look at another example. Okay, the marketing manager of a company has noted that she usually receives 10 complaint calls from customers during a working week. So 10 calls during a working week, and then a working week is a 5-day week. So in a 5-day, so receive 10 calls in 5 days. Okay, and then these calls occur at random. So find the probability of her receiving more than 1 call in a single day. So we want probability of more than 1 in a single day. Okay, let's say this one. We say X. We can say X is actually number of calls in 5 days. Okay, and then average she received 10 complaint calls in 5 days. So we can say X is a Poisson distribution where the mean equals to 10. Okay, but now we want to calculate probability of receiving more than 1. So this one is basically more than 1 without, there's no equal sign, more than 1, in a single day. So now we let Y is actually the number of calls in one day, in a day. So if in 5 days she received 10 calls, so in a day actually, so she only received 10 divided by 5. So she only received 2 calls in a day. So 2 calls in a day. So we can say Y is Poisson distribution with the mean equals to 2. Okay, and now we want to find probability of Y greater than 1. Okay, and then again, this one is Poisson. It can go up to infinity, so we use the complement rule. So this one is 1 minus probability of Y less than or equals to 1. So this one is 1 minus, then bracket, probability of Y equals to 0 plus probability of Y equals to 1. Can I remember? Okay, let's calculate this one first. So this one, 1 minus and then bracket, so I use the formula. So the mean, which is 2, okay, wait. So let's just start with exponent. So e to the power of negative mean, negative 2, and then times 2 to the power of x, which is 0, and then divide by 0 factorial, and then plus e to the power of negative mean, so negative 2, and then 2 to the power of x to the power of 1, divided by 1 factorial. So this one is 1 minus bracket 0.1353 plus 0.2707. So the answer here is, the final answer is 0.5940. Okay, for Poisson, the interval is really important. So remember, if in the 5 days, the average is 10, that's why we have this one, x. But right now, we want to calculate the probability of receiving more than 1 call in a single day. That's why instead of x, we define another new random variable y. So this one is actually number of calls in a day. So now the average is 2 because 10 divided by 5 days. So that's why we use y instead of x here. So remember, interval is very important for Poisson distribution. Okay. So let's look at another example. In a study of business activity at a restaurant, so it is found that the average number of customers arriving between 10 to 11 p.m. So basically this is the interval, 10 to 11 p.m. on Monday night. Okay, so this whole thing is 5. So this one is the mean. It's 5. So using Poisson distribution, find the probability that 1 or 2 customers will arrive at that time. So we are right now calculating the probability in the same interval. So we can just use this mean. So we know x is a Poisson distribution with mean equals to 5. Okay, and then now we want to find probability of x equals to 1 or 2. So x equals to 1 or x equals to 2. And then remember, these are mutually exclusive events. So for this one, we just add these two probability. Probability of x equals to 1 plus probability of x equals to 2. So we use the formula e to the power of mean, a negative mean, e to the power of negative 5, and then 5 to the power of 1 divided by 1 factorial plus e to the power of negative 5, and then 5 to the power of 2 divided by 2 factorial. So the answer here is 0.1179. Okay, B. What are the mean and the standard deviation of this probability distribution? Okay, remember the mean equals to the mean, which is 5. So we get the mean. Okay, and then the standard deviation, sigma, is actually equals to square root of variance. Okay, and then remember, for Poisson, the mean and variance is actually the same. So the variance also equals to 5. So this one is square root of 5. So this one is equals to 2.2361. Okay. Okay, basically, right now you are left with exercise. So for exercise 1, I want you guys to try this one yourself. Okay, so this one is the discrete probability distribution. So for A, what is the value of y? So I just give the final answer. So y equals to 0.3. And then for B, find the expected value and the standard deviation for the above distribution. So the expected value, the answer is 2.9. And then the standard deviation, sigma, is equals to 1.1358. So I want you guys to try this yourself. Okay, for question 2 also, I want you guys to try yourself. So you have to identify what distribution this x has. So I'll just give the final answer. So for A, the final answer is 0.2668. And then for B, the final answer is 0.0014. Okay, so you try yourself for this one, for these two questions. Okay, let's look at question 3. So let's discuss question 3. So if a random variable x is such that x is a binomial distribution, so the n equals to 10, and then we have the p, probability of success. Okay, and then p is less than half. And then we also given the variance is 15/8. So find the value of p. Okay, for this one actually, what we can do is we can use whatever formula we have. So we know we have e of x equals to n times p. And then we also have the variance of x equals to n times p times q. And then we don't have e of x, but we have the variance, which is 15/8. So we can use the formula for variance to find p. So we know variance of x is equals to n times p times q. And then the variance is 15/8 equals to, okay, we know n, which is 10. And then times p, and then times q. And then q also we can write in terms of p, which is 1 minus p. Okay, and then we can expand the bracket on the right side. So over here is 15/8 equals to 10, and then times p minus p squared. And then the 10 we can bring down this 10. So we have over here is 0.1875 equals to p minus p squared. So everything we can bring to the right hand side. So p squared minus p plus 0.1875 equals to 0. So this is quadratic equation. So we can solve this one. And then when we solve, actually we will get two values of p. So we will get p equals to 0.75, and then another one is p equals to 0.25. And then remember, we have p less than half. So the answer here is actually p equals to 0.25. So we get here p equals to 0.25. And then b, we want to calculate e of x. So e of x is actually n times p, which is equals to 10 times 0.25. So we get equals to 2.5. So now C, we want to calculate probability of x equals to 2. So this one is actually equals to 10 choose 2. And then times P, 0.25 to the power of 2. And then times Q, which is 0.75 to the power of 8. So the answer here is 0.2816. Okay, let's look at last question. Okay, a book containing 400 pages has 700 misprint. So this book has 400 pages, and this book also has 700 misprints. So what is the average number of misprint per page? So for this one, the answer will be 700 misprint divided by 400 pages. So we get 1.75 misprint per page. Okay, misprint per page. 1.75 misprint per page. So find the probability that page 333 contains no misprint. So basically this one is like probability of, so if you look at this, we have on average 1.75 misprint per page. So we can define x equals to number of misprint per page. In one page. And then we know average per page is actually 1.75. So we can say x is Poisson distribution with mean equals to 1.75. Okay, and then we want to find probability that page 333 contains no misprint. So page 333 is actually only one page. So this one is actually, we want to find probability of x equals to 0. So this one we use the formula for Poisson. So e to the power of negative 1.75. And then 1.75 to the power of 0 divided by 0 factorial. So the answer here is 0.1738. Okay, and then for question 2, again, this one is exactly 3 misprints. So this one also probability of x equals to 3. So we use the formula. So for this one, so you just sub in the formula, just replace the x equals to 3 now. So the final answer here is 0.1552. Okay, C. Find the probability that pages 235 and 344 will contain no misprint. So basically we want to look at 2 pages now. So instead of we want to calculate probability of in one page only per page. So basically we want to calculate the probability in 2 pages now. So we define y as the number of misprint in 2 page per 2 pages. And then the mean here now will be equals to 1.75 times 2. So the mean here will be equals to 3.5. So we can say y is Poisson distribution with mean equals to 3.5. And then we want to calculate probability of y equals to 0. So we use the formula. So I just give the final answer for this one. The final answer is 0.0302. Okay, I think that's all for today. Okay, thank you everyone.